Dear students, hope all of you are doing good. In this video, we are going to discuss another aspect of phase equilibria, that is distillation of liquid mixture principle and what is azeotropic mixture. What are the points we are going to discuss in this video are: number 1, vapor pressure composition curve and boiling point composition curve for completely miscible liquid binary mixture. Then what is the principle of distillation of binary liquid solution, and number 4 is the azeotropic mixture. So let's first start with vapor pressure composition curve and boiling point composition curve for completely miscible liquid binary mixture. Now, since we know that if at a particular temperature the vapor pressure is equal to the atmospheric pressure, then it indicates the boiling point of the compound. So the boiling point of the compound is that temperature at which temperature the vapor pressure is equal to the atmospheric pressure. Now, to draw a phase diagram, we need two variables. Either it may be pressure temperature, or it may be pressure composition, or it may be temperature composition. Now, if we draw the pressure composition curve for a miscible binary mixture, suppose A and B, then here in x-axis it represents the mole fraction of B, and in y-axis it is the vapor pressure, and the mole fraction of B represents, as it increases up to 1, that means the right hand side of the diagram represents the composition of B, and since in left hand side it indicates 0, that means in left hand side it is the composition of A. That means from increasing from 0 to 1, the composition of B is increases from A. Now we are getting two curves. One is liquid curve, one is vapor curve. That means among A and B, the vapor pressure of B is more compared to A. Hence, in this curve, temperature is constant. Hence, for a particular vapor pressure, at a particular point of vapor pressure, the composition of A is rich in liquid, and at that pressure the composition of B is rich in vapor, which indicates in the right hand side. And in the left hand side, at a particular pressure, here this point, the composition of A is rich and it is in the liquid, and at that pressure the composition of B is in vapor, and which is in right hand side. Now, to get the boiling point for a particular compound, that it may be A or it may be B, the vapor pressure should be equal to the atmospheric pressure. So since atmospheric pressure is constant, so as the vapor pressure increases, then the boiling point will be decreases. Hence, we can say that the lower vapor pressure means the boiling point for A will be increased, and higher vapor pressure means the boiling point of B will be decreased. So, if we draw the temperature composition curve, that is boiling point composition curve, we will see the reverse order. Why? Because here vapor pressure is low for the fraction of A, boiling point will be high, and vapor pressure is high, boiling point will be low. And here the lower curve will indicate the liquid curve and upper curve will indicate the vapor curve. So it is reverse compared to the vapor pressure composition curve. Why? Because this is the principle that vapor pressure is equal to atmospheric pressure, which indicate the boiling point. So atmospheric pressure is constant. As the vapor pressure is increased, then to reach the atmospheric pressure, boiling point, the temperature will need low. So boiling point will be decreased. And if the vapor pressure is low, then to get the atmospheric pressure, the temperature should require high. So boiling point will be high. And this is the reverse order. Boiling point composition curve is the reverse compared to the vapor pressure composition curve. Hence, from this we are getting a boiling point composition curve of type this one for a binary mixer. Now, applying this principle, we can apply for the distillation, fractional distillation process. Suppose we are taking a binary mixer of A and B, similar like earlier boiling temperature and mole fraction curve, composition curve. At a particular temperature T, the vapor pressure of composition X1, the vapor pressure of the composition X1, which is richer in B, since it is right hand side. And at this point, the composition will be as X, which is richer. This is residual liquid, this is in liquid state, it is in rich in A because it is in left hand side. So for a particular temperature T, the composition X is in liquid state, which is rich in A, and the composition X1 is in vapor state, which is in rich in B. As the temperature increases T1, the composition for the Y, which is liquid, which is rich in A, and composition for X2, which is in vapor, which is rich in B. So as the distillation process continue, finally we will get a temperature TA, which is the boiling point for A, where the composition is in liquid, which is rich in A. The complete residual liquid will become A, and the vapor will become of rich in B. So by applying this process, we can distill. We can say that if the process is continued, the boiling point of the solution will go on rising from T to TA, and then the composition of the residual liquid will become richer in A, and only liquid A will remain in the liquid phase, and the vapor will distill off as pure B. So this is the principle of the fractional distillation process. Now sometimes in this process we may get that the curve will show a minimum composition curve, minimum point C, where the liquid mixer and the vapor is in the same composition. In this case, the composition of liquid and the composition of vapor is constant, and at this point the liquid mixer boils at constant temperature without change of the composition, and such mixer, this type of mixer where we are getting two curves of liquid vapor with a minimum composition and at constant temperature, it is called azeotropic mixer or constant boiling mixer. So what is azeotropic mixer? That the boiling temperature and the composition curve meet at minimum point C, where the liquid mixer and the vapor phase has the same composition, and at this point C, the liquid mixer boils at constant temperature without change of the composition, and such mixer is called constant boiling mixer or azeotropic mixer. Now, if we see here, at temperature T, the composition of X1, which is in vapor phase, is reached in constant boiling mixer. That means it is in this side, constant boiling mixer. And the composition of X at that temperature, this is X, not X1, this is X, at the composition X, which is in liquid state, is reached in A, because it is in left hand side. As the distillation proceeds, the composition of the distillate will change towards C. The distillate will change towards C, and the residual solution will change towards A as the distillation proceeds. And ultimately, the mixture of pure A liquid will be left as the residue, and the mixture of the minimum boiling point composition will be obtained as distillate. I am considering only this curve. And in this state, it will never be possible to have B. In this curve, in this case, we will not get pure B. Only we will get pure A. How? That at temperature T, the liquid composition will reach in A, and the vapor composition is reached in liquid mixer. As the distillation process, we will get a minimum composition C, where it will distill at constant temperature, and finally we will get that the vapor phase will completely, it is a constant boiling mixer, and the residual liquid will be pure A. And in this case, we will not get pure B. Similarly, if we consider this curve, then the composition of Y1, which is rich in constant boiling mixer, this way, and composition of Y, which is rich in B, that is in right hand side. So as the distillation proceeds, we will get a pure composition of B and a constant boiling mixer. So from this curve we will get pure B, and from this curve we will get pure A. So this type of mixer, where there is a minimum point, the curve meet at minimum point, where the liquid mixer and the vapor phase has the same composition and it boils at constant temperature small t. This type of mixer is called azeotropic mixer. So that's all for today. Thank you.